So this lesson is from Chapter 6, Lesson 6. We're going to look at adding and subtracting mixed numbers with unlike denominators. So it's pretty similar to when we added and subtracted just regular fractions with unlike denominators. It's the same thing, except now we're adding in a whole number because these are now mixed numbers. So I have this problem, 1 4/5 plus 2 1/10. Well, I can't add them because I have different denominators. I have a 5 and a 10. So I need to first find a common denominator. So I need to use the common denominator then to write equivalent fractions with like denominators. So I'm going to use my normal steps. I'm going to find the LCD by finding a list. So I'm going to find my LCD. I'm going to pull out the 5 and the 10. So 5 times 1 is 5. 5 times 2 is 10. Oh, I'm not going to go any further because I know that 10 times 1 is 10. So my common denominator is going to be 10, which is perfect because this one is already 10, which means I only need to fix one of these mixed numbers. So I'm going to rewrite this problem the up and down way, the vertical way, like we do normal math problems in the classroom. So I'm going to start off by just changing the direction of it. 1 4/5 plus 2 1/10. So now I'm going to put the new fractions next to the original fraction. So I'm going to put their equivalents next to it so I can add them. So with mixed numbers, my whole number can stay the same. And now I'm going to just change my fraction. I need to change it into something over 10 because that's my new denominator. So I'm asking myself, how did I get from 5 to 10? What did I multiply by? Well, I multiplied by 2. So what I do to the bottom, I do the exact same thing to the top. So 4 times 2 is 8. And now I can actually keep this whole number 2 the same, and I can keep this whole fraction the same because the denominator is already 10, which is really nice. Now that I have common denominators, I can add. And when I add mixed numbers, I first start by adding the fractions. So I'm saying 8 plus 1 is 9. The denominators stay the same. And then I move to my whole numbers. 1 plus 2 is 3. And I check to make sure that 9/10 is in simplest form, meaning is the only number I can divide the top and bottom by 1? Yep, so 3 9/10 is my final answer. Let's look at a subtraction of mixed numbers. The problem I have here is 4 5/6 minus 2 3/4. So I'm going to first rewrite this up and down vertically. 4 5/6 minus 2 3/4. And I know that I'm going to need to find a common denominator because I have 6 and I have 4, and I can't subtract those two. So I'm going to find the LCD, the least common denominator, for 6 and for 4. So 6 times 1 is 6. 6 times 2 is 12. 6 times 3 is 18. 6 times 4 is 24. 6 times 5 is 30. 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. 4 times 5 is 20. 4 times 6 is 24. So now I'm going to look for common multiples. I see that I have 12 the same. I also see that I have 24 the same. Now, if you were doing it the first way, when we talked about common denominators, you would have just multiplied 6 times 4 and gotten 24. But then you would have had to simplify it. Now, if I'm going to do the least common denominator, chances are, if I have to do any simplifying, it's going to be very little simplifying. So I'm going to use my denominator of 12. So when we rewrite our fractions and our mixed numbers, we keep the whole number the same. 4 stays the same. And instead of 6, I'm going to use my new denominator of 12. So I'm asking myself now, 6 times what got me to 12? Well, 6 times 2 got me to 12. So what I do to the bottom, I do the exact same thing to the top. So I'm going to multiply it by 2. So 5 times 2 is 10. Bring down my subtraction symbol, bring over my 2, make my 4 into my new denominator of 12. So now I'm saying 4 times what number gave me 12? Well, that was 3. So what I do to the bottom, I do the exact same thing to the top. So 3 times 3 is 9. Now, since I have common denominators, I can subtract. Since I'm subtracting mixed numbers, I start subtracting with the fractions. So 10 minus 9 is 1. The denominators will stay the same. And now I subtract 4 minus 2, and that gives me 2. So before I say I'm done, I need to check to make sure I don't need to simplify. So remember, when you simplify, you divide the top and bottom by the exact same number. So I could do 12 divided by 2, but can I do 1 divided by 2? Nope. When your numerator has a 1 in its spot, you know that you are in simplest form. So I am totally done with this problem. My answer is 2 and 1/12.